That's really close. Okay, action.
Hi guys. So guess what? We're moving on to a new topic. We're done with converting measurements. I know how much you probably all loved that topic. It was hard, right? So we're going to move on, and I think you're going to like this topic because it's kind of cool, it's kind of easy, and we definitely will be able to use it in the future. So this is lesson 12, and lesson 12 is about measuring data, and data is any information that you collect. So if you look at the solve and share on page 699, it says, several students were asked how many blocks they walk from home to school each day. The results are shown in the line plot below. So this kind of a graphic is called a line plot. How many students were asked the question? Use the line plot to solve this problem. So to find out the first question, how many students were asked, if all of your data is shown on the line plot, then you would just have to count up the number of dots that you see because each dot represents a question that was asked. So if you were to count all of these together, 1, 2, 3, 4 here, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, 1, 2 here, and 1 here. If you were to add all of those up together, you should get 25, okay? And that means that there were 25 people asked. So under look back it says, well, what can you tell about the distance most of the students in the group walked? So now we're asking you to judge the data, make an observation. So we could observe that, well, most of them are about 4 blocks away, or very few are more than 4. We could say most of them are 4 or less. 4 or less blocks away from school. Okay? So if we want to go over to page 701, I'm just going to go to number 1 here. What is an outlier in a set of data? An outlier. An outlier in a set of data is one that is so far away from the group that it's like an exception. It doesn't really go along with the rest. An outlier is something different from what we see most of the time. Number 2. In the line plot on the previous page, do any values occur the same number of times? Explain. Well, yeah, right? We have 5 people lived 2 blocks away, and 5 also people lived 3 blocks away. Okay? Number 3, describe any patterns in a line plot on the previous page. So again, you could just say, well, most of the people live between 1 and 4 blocks away. That would be an example answer. So looking at do you know how? Mr. Rice's students ran a 40-yard dash in the following times in seconds. How many race times are recorded? Well, just like we counted here, we can count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 pieces of data. Use the line plot to show the data. So now I'm taking each of these and I'm plotting, like 6.8 would go here, 7.3 would go here. And you would just go along and plot that data. And now that they've done that for you, which time occurred most? Well, just look at the one that has the highest amount and you can easily see it's going to be 7.1. Okay? So that's basically how you're going to go about analyzing line plots. Can you make a line plot yourself? Yes, you can. Okay? You could, for example, if they didn't give you these, you could for yourself do this, 7.3. You could put in your own. They're not always going to give them for you in the future. They might give you these and you might have to put it in. But that's the basic of it. Okay? So I hope you have a good time with this. Do the practice buddy. And on Google Classroom, if you have any questions, let me know. Thank you. Bye.